I'm going to do a proof for Thevenin's theorem. So just I'm going to consider a simple circuit and I'm going to prove a Thevenin's theorems. I'm going to consider a general diagram. Consider a voltage is E1, then impedance Z1, Z2, Z1, Z2, then load impedance Z3. Consider this is Z3. Consider this is a load terminals A and this is B. So here, what is the Thevenin's theorem says that? Thevenin's theorem says that we need to convert this a network, okay, into its equivalent here. So we are going to calculate, we are going to convert, first we are going to calculate VTH, means load voltages VTH plus minus VTH, then total resistance ZTH, then connect load. So this is load Z3. So this is the equivalent circuit. So what is this? This is a normal circuit and this is the Thevenin's equivalent circuit. Thevenin's equivalent circuit. Now we want to prove this. How we are going to prove this? It is very simple. Now I am going to calculate here a current passing through this. Okay, should be equal to current passing through this. So if you proved current passing through Z3 is equal to a current passing through Z3 in this network, it shows that we have proved Thevenin's theorem. First, I am going to calculate a current passing through Z3 in network A. Consider this is network A and this is the network B. Correct? So I am going to calculate a current passing through Z3 in a network A. Then I am going to calculate a current passing through a Z3 in the network B. Both should be equal. Correct? Well, first I am going to consider a network A and I am going to calculate currents. So consider a network A. So this is plus minus Z1 Z2 and Z3. So this is Z3, so this is Z2 and this is Z1 and this is E1. So I want to calculate a current passing through Z3. I'm going to consider current passing in the first loop is I1 and current passing is I2. So here I want to calculate I2 current because I2 current is passing through Z3. So here first I am going to write equations, loop equations. uh, loop 1, it's very simple. I1 is passing now. I'm going to apply a KVL here. So here I1 Z1 plus I1 here. I1 Z1 and current is passing here. I1 Z2, then two currents passing through Z2. One is I1 in this direction and I2 is in opposite direction. So that's why we need to write minus I2 Z2. Then I'm going like this. It is minus E1 equal to 0, or you can write plus E1 this side, because minus E1 equal to 0. I'm going to shift this even this side. Okay. Then here I1 is take common take outside Z1 plus Z2 into I1 minus I2 into Z2, which is equal to E1. Now call this equations 1. Similarly, apply a KVL at loop 2. So loop 2, apply any KVL for the loop 2, then I2, okay, behind Z3 I2, because here I2 is flowing through this, Z3 I2 plus Z2 I2, okay, Z2 I2, and through Z2 two currents are passing, one I2 in this directions but I1 in opposite directions, so that's why I'm going to consider minus Z2 I1 equal to 0. Then just arrange in this I1 and I2 order, so minus Z2 I1 plus here I2 is common, take outside, Z3 plus Z2 equal to 0. Call this equation 2. So here I want to apply Cramer's rule. Okay, I want to apply Cramer's rule to calculate the values of I1 and I2. So just I'm going to arranging in matrix form. I1 coefficient is Z1 plus Z2. Here minus Z2 so here minus Z2 and here Z2 plus Z3. Okay. Now so just I'm going to calculate a D here. So D here Z1 plus Z2 into Z2 plus Z3. Okay. Minus of minus, it becomes a plus, again it minus Z2 square. Just open the bracket here, Z1 Z2 plus Z1 Z3 plus Z2 square plus Z2 square plus Z2 Z3 minus Z2 square. So plus Z2 square and minus Z2 square get cancelled. What is D? D becomes Z1 Z2 plus Z1 Z3 plus Z2 Z3. So here look at the observed network very carefully. So I want to calculate current passing through Z3 here. Then I want to concentrate only on I2. I want I2 only because load correct. So when how we are going to calculate I2? I2 is equal to D2 by D. So what is that I2? I2 is equal to D2 by D. So we have calculated D here. We need to calculate D2. What is that D2? Okay, D2 is equal to, it's very simple. So here first column keep as it is, Z1 plus Z2. So here Z1 plus Z2, Z2, okay, Z2. Then so second column we need to replace this coefficient even and 0, even and 0. So this is even and this is 0. So this is D2. So here multiplications of these, okay, Z1 plus Z2 into 0 is becomes a 0 minus even, okay, even Z2, okay, minus even Z2. 1 minute. Okay. Okay, see here. So here I1 coefficient is minus Z2. Yeah, so this is minus Z2. Fine. Yeah, this is minus Z2. Fine. Okay. So here this is 0 minus of minus, it becomes a plus even Z2. So this is D2. Then calculate I2 very easily. So what is that D2? Even, okay, even Z2 divided by what is D here? D we already calculated, Z1 plus Z2 plus Z1 Z2 plus Z1 Z3 plus Z2 Z3. So here we have calculated, current passing through load using normal method. Then we need to, yeah, then we need to calculate the current passing through Z3 in the network B. Then we have calculated this current passing through Z3 is normal method, that should be equal to this. then I'm going to consider second a network B. Okay, I'm going to consider a network B here. So here plus minus VTH and connected in series with ZTH and in series with the load Z3. So here in this network we want to calculate current passing through Z3. So before that we need to calculate VTH. What is VTH? Then we need to calculate ZTH. So here it is very simple. VTH, just I'm going to consider a given network here. Given network plus minus so this is Z3, Z2 and this is Z1 and this is E1. So consider this is a normal network. So first what I'm doing, consider this is a terminal A and this is a B. Okay. So how to calculate an VTH here? It is very simple. First you need to follow some steps. First open the load. Open the load, then we need to calculate load voltage. We need to calculate load voltage, that is VTH. See here, just I am open the load here. Okay, then its circuit becomes like this, plus minus even. Okay, it is Z1 and it is Z2. See, open the load like this. Open the load EV. Now we want to calculate load voltages. This is VTH, correct? So what is the how we can calculate any VTH from this diagram? It is very simple. VTH is equal to, we need to calculate current passing through Z2. So that is I. Okay, I. Consider that current passing through Z2 is I into R. So I into Z2 is nothing but VTH across the AB. So I want to calculate a current I passing through Z2. Correct? Yeah. Just uh, yes. Okay. Apply a loop analysis. Yes. Okay. It is very simple. So what is that here? I is equal to V by R. What is V here? E1 divided by R means 2 resistance. So Z1 plus Z2. Z1 plus Z2. So this is I. Correct? I. Then I into I into Z2 is nothing but voltage across uh, VAB. So that is VTH, which is equal to Z2 into I into Z2. So here multiplying with, so then it becomes E1 into Z2 divided by Z1 plus Z2. So this is an VTH. So we have calculated VTH. VTH is equal to E1 Z2 divided by Z1 plus Z2. Then we need to calculate ZTH. So how we are going to calculate ZTH? It is very simple. So consider this network and short the voltage source and open the current source. Here there is no current source at all. So just here short the voltage source. Then short the voltage source, then it becomes Z1 and Z2 are in parallel. So here ZTH is Z1 and Z2 are parallel. So can you written as Z1 into Z2 divided by Z1 plus Z2. So this is the ZTH. Correct? Then what is our aim? Our aim then, see here, we have calculated VTH and we have calculated ZTH, and just we need to connect load that, and I want to calculate this current. Correct? Okay. So here just I write equations here. Consider it is plus minus. So this is VTH and this is a ZTH, and this is the current, sorry, this is the load is Z3 here. Okay, so here VTH we have calculated, so I want to calculate a current. Okay, this current, correct? Okay, now what is that VTH? We have calculated that. I'm going to write that even Z2 divided by Z1 plus Z2. So here even Z2 divided by Z1 plus Z2. So what is ZTH? ZTH is Z1 Z2 divided by Z1 plus Z2. Z1 Z2 divided by Z1 plus Z2. So this is the current I want to calculate here. So what is that current? I is equal to V by R. V by R. So what is here? V is VTH. VTH is nothing but E1 into Z2 divided by Z1 plus Z2. This is V by R is this total. So here Z3 plus Z1 into Z2 divided by Z1 plus Z2. Then simplify this, we're going to get high. So here E1 into Z2 divided by Z1 plus Z2, then divided by, so take LCM, Z1 plus Z2, then multiplied by this, so Z1 Z3 plus Z2 Z3 plus Z1 Z2. So here this is Z2. So yes, okay, even divided by this, yeah, and so this Z1 and Z1 Z2 Z1 Z2 get cancelled. So what is the final answer? High. So final answer high is equal to even Z2 divided by Z1 Z3 plus Z2 Z3 plus Z1 Z2. So this is the final answers current passing through Thevenin's load. Now, so observe very carefully. Now, so here this and, okay, this and, yeah, this and this are same. Okay, okay, see here. Even Z2 divided by Z1 Z2 Z1 Z3 Z2. Okay, even Z2. So yes, see, even Z2 divided by Z1 plus Z3 plus Z2 plus Z3 plus Z1 Z2. So here what it showed that, we have put this. Okay, so here first we have calculated current passing through Z3 using normal method. Okay, then we have we return Thevenin's equivalent VTH and ZTH and connected load. So we have calculated current passing through this and current passing through this, both are same. So this is using normal method we have calculated, and this is we have calculated using Thevenin's method. So both the answer is correct, hence we proved the Thevenin's theorems. Thank you.